Hi folks, in this video, I'm going to go through the Python code we developed to implement the random forest model. So I already covered, what this random forest model is trying to model in the previous two videos. So this is my Jupyter Notebook screen, and in this folder, we have like data folder, including the data files, and also the Python code, random forest rip channel. So inside this data folder, I already put x1 to x5 CSV files that I stored the heights of the fins in the channel. So as I explained in the previous video, so we're considering a rough channel including five roughness in the geometries. And x1 basically corresponds, x1.csv file include the heights of the first roughness geometry for the 243 cases. So if you open up x1 file, so you will see the height of the first roughness for the 243 examples. But in this particular x1 CSV file, I included the value of the heights of the all five reef roughness. So, but for the Python implementation, so I only included this A1, A column, and then saved, right? So I have x1 for the height of the first roughness. X2 includes the heights of the second roughness, and yeah, it repeats until the fifth roughness. And y1 to y5 data file includes the convection coefficient at the first roughness location. Y2 includes the second roughnesses convection coefficient values, and it repeats until y5. So that's basically the data file to run this random forest model. And then if you go back, now we have the main code here. So let's go through this code. So to run the random forest model, we need to incorporate several packages such as NumPy and Pandas. So these are really, basic packages when you're dealing with arrays. And we need a matplot library, so which is required to make some plots, right? And for the random forest training, we use skitlearn libraries, and in here I imported five libraries packages. So first one is needed to split the data set into training and test data set. And second package is required to scale your data between 0 and 1. And then the third one and fourth one are required to do k-fold cross-validation. And then the final one, ensemble module or library, is needed to train your random forest model, right? So these are, so the first cell basically imports some required packages. And now in the second cell, I define the data import. Okay, so you need to import your data file, yeah, to train your model. So so capital X here, X array basically stores all the input feature data, and small y array basically stores all the answer data, which is corresponding to convection heat transfer coefficient, right? And then once you imported your X and Y data, you will need to split them into training and test data sets. So basically we are making X train, X test arrays. So here we store the height information of your rough channel, and here you can set how many percentage corresponds to um, the test data set. So if you put like 0.25, 25% of the entire data set will be used to test your random forest model, but 75% of the data set will be used to training your model, right? And then yeah, we also generate the training and testing data set for the Y values, right? And to compare the random forest prediction with the true answer, we also make an array. So CFDH is the true answer generated by your numerical simulation model. So and this Y so true answer array includes both training and testing data sets Y values, right? So this is the second cell defining how we import data and also how we split the data set into training and testing sets. And in the next cell, all right, so this is actually more direct code, direct lines, reading the data. So as I explained just a couple of minutes ago, I stored the values of the height of the first cell in x1.csv, right? And also I stored the convection coefficient value for that height in y1.csv. So basically we actually import x1 to x5, y1 to y5 CSV files using this read data function, which we define in the above cell, right? And then we generate those testing, training arrays, right? Right. So that's the function of the second cell, and then and again, so when you import the entire training data set, and then if you split them into training and testing data set, this code actually randomly select the 75% of the data set as training set and randomly select 25% of the data set as testing set. So you want to store them to see which cases have been chosen as training set and which cases have been chosen as testing set. So these lines basically save the training set and testing set as X train the CSV, Y train the CSV files, and X test.csv and Y test CSV files. So if you go back to this data folder, now you see that those CSV files were generated after I ran this part of the code. So I already run this code before. So so these four CSV files were generated, which show which cases, which instances were chosen as testing or training sets, right? And now we define a cell, right? A function where we actually train your model, and also we implement cross-validation. So here, TLF.feed function actually obtain the training data set, and then it's gonna train your random forest model. So we have another function shown below, which will determine the settings of your training. But first of all, yeah, let's focus on this cell, and again in the skitlearn package, now you can do cross-fold, k-fold cross-validation here. So you can use this function to do k-fold cross-validation, right? So here we split the dataset into 4. And then we're going to use those subset of datasets to train your model and then compare the results, okay? So we will actually understand how data sampling affect the model accuracy through running this cross-validation. All right, yeah, let's go to the next cell here. So here we can define the settings for the model training. Okay, so model training is the function we define in this cell. So basically, this function will obtain the training data set, testing data set, and this is simply our input that identifies the location of the rib. So remember, we have 5 ribs, so you can identify the first, second, third, or fourth or fifth rib. Okay, so this is the number you're gonna put in, and then here now you can define the training model. So again, we're going to use random forest model, right? So this is the function defined in skitlearn. And then we define the number of trees. How many trees will be included in this forest? So we say 10. Of course, you can vary this number to test the effect of the number of trees. This number, 42, determines the seed for your random number generator. So when you're training your random forest model, so you can also explain how the seed of random number generator affects your model result, right? And then next lines are simply the functions that return the values of the coefficient of determination for your training data set or testing data set. So you're gonna, as I said, you're gonna put the rib identifier number here. And so the data name will be determined by this identifier plus just retraining text. And then we will see, we will get the coefficient of determination at this corresponding rib identifier. So we can check the accuracy of the model at this particular rib location. So if you put 1 as the rib identifier, so this function will return the accuracy of the model at the first rib location. But if you put like 5 as the rib identifier, we will see the accuracy at the 5th rib location, right? And we also ask our model to return feature importance. So, so these values, feature importance, mean how critical that feature is regarding the accuracy of the model prediction, right? So we will see the examples in the following cell. All right, so this is the actual cell that actually running the function we defined here, model training. So basically we are going to use the training data set, testing data set, and the REAP identifier is simply the combine. So basically we're using all 5 REAPs here because yeah, we didn't the training data set basically include all 5 REAP locations. So basically we are getting the we're actually getting the accuracy values for the all 5 REAP locations. And if you run this code, this cell, now you're gonna get the following result. All right. So the coefficient of determination for the all training set was 0.99, highly accurate. And after you did cross-fold, sorry, k-fold cross-validation, the accuracy is 0.99. So meaning that sampling, so how you sample your training data set actually does not really affect your model accuracy. Maybe this problem is not highly difficult because you only have 5 roughnesses in your channel. So, but if you have longer channel and much more number of reefs, then sampling, of course, will matter, and the coefficient of determination will go down. And in the next 2 lines, now we see the scores from the testing data set. Okay, so testing data sets are the data set we didn't use for training, but even for those cases, our model exhibited pretty high accuracy, 0.99. And now the random forest model gave us the feature importance. Because we have 5, 1, 2, 3, 4, 5, 6. So it actually returned 6 feature importance value. And but actually the first 5 values correspond to the importance of the first rib height, second rib height, third, fourth, fifth rib height. Okay, so the first rib height is really important when determining the convection coefficients of all rib locations. Okay, so yeah, so the first rib actually plays really dominating effect along the channel, but as the flows passes through the rough channel, the following ribs height actually plays a less important effect when determining the convection coefficient. So we can actually see that effect from this feature importance array, right? And in the next cell, we're actually storing the convection coefficient values predicted by random forest model with the training data sets the x values and also testing data sets x value, right? So we are storing the y values here because this training function does not really store how our model really predicted for these x values, right? So here we explicitly store the predicted values by our train model. And then in the next cell, we simply combine the h value for the first, second, third, fourth, and fifth ribs just for the plotting purpose. Okay. And then now here you can plot the convection coefficient at the first RIP location, which was predicted by our random forest model. And also CFD is the true value. And now you see that in most of the example cases, our random forest prediction and CFD values, they align pretty well, although there are some outliers here. And here we plotted the convection coefficient at the second RIPS, and here there are not many outliers, although there is one here. And in the third RIP, okay, our data random forest prediction really align well with the CFD, although there's one outlier, and it repeats all the way to in the fifth RIP. And now you see that there's a consistent outlier. It can be maybe the mistake in your CFD model, or maybe this data point is too difficult for random forest model to get trained, right? So for the successful training of your model, it's really important to look at what this outlier is. So that's why we stored the predicted values from the training data set or testing data set. So while checking this value, you can also identify which channel geometry really generated this outlier. So going back to your simulation model and checking the complexity or the accuracy of this outlier is really important to improve your CFD accuracy and also random forest accuracy. So this is a really brief go through of the random forest model for our problem, and hope that this is really helpful to build your model. Thank you.